Hello. In this video, I want to look at the topic of proving trigonometric identities. So, for an opening example, let me take this identity, that the sine of 2x is equal to 2 times the tangent of x divided by the secant squared of x. Now, when I want to prove trig identities, the guideline is that I've got to start on one side and change one side into the other side. So I could start with sine 2x and working on that side alone, transform it to 2 tangent x divided by secant squared x. Or I could start on the right side and transform it to the left. So let's take this right side, because there's something I want to show you here. I want to show you something here. Now, especially when you get into calculus, you want to look at this as 2 times the tangent of x divided by secant squared x. You want to look at this as 2 tangent x times 1 over secant squared x. You see, I've pulled that denominator term off to the side, perfectly legal. But now remember your reciprocals, and remember that the secant is the reciprocal of the cosine. So 1 over secant squared x would be the same as cosine squared x. Now remember where I want to get. I want to get to the sine of 2x. Remember, sine 2x is 2 times sine x times cosine x. And you might begin to see that I'm almost there, because I can take tangent x and write that as sine x divided by cosine x, tangent, times cosine squared x. Now you see I've got that, because cosine x, cosine squared x. So this cosine x factors one of these, and I'm left then with 2 sine x times cosine x, which is what I wanted, which is the sine of 2x. Alrighty? Now, your challenge, I'll pass on to you, is now you take this example. Now you start on this side, and you transform sine 2x into 2 tangent x divided by sine squared x, or divided by secant squared x. Okay, let's take a look at a second example. Now, in the second example, I'm going to take 1 minus sine theta divided by 1 plus sine theta, and I would like to prove it is equal to secant theta minus tangent theta squared. And I must say, I've got my work cut out for me, because the rule is I can only work on one side of the identity, not both. And you might wonder, looking at this, well, gosh, which side would I work with? Well, we're going to have to fudge a little bit, but I'll show you what we're going to do. Let's go ahead and FOIL the right side. So I have secant squared theta minus 2 secant theta times tan theta plus tan squared theta. Went ahead and FOILed that right side. And you might be thinking, and I'd be right there with you, how in goodness do we transform the left side to the right side? Alrighty, let's multiply this fraction by the conjugate of this denominator. Now again, this is kind of cheating, and this is not the proof, this is just to help me out. So I'm going to take 1 minus sine theta over 1 plus sine theta and multiply by 1 minus sine over 1 minus sine theta. Now by doing that, up top, I've got 1 minus 2 sine theta plus sine squared theta. Down below, 1 minus sine squared theta. 1 minus sine squared theta is cosine squared theta. So each piece here can be put over cosine squared theta. Check that out. Okay? So again, 1 plus sine theta times 1 minus sine theta would be 1 minus sine squared theta, which by Pythagorean identity is cosine squared theta. And since that's one term, I can write each term in the numerator over that denominator. Now, if you look what I want, I've got it. Because 1 over cosine squared is the secant squared, and gosh, if I pull this cosine apart, as I did before, leave one cosine under the sine, the other 1 over cosine becomes a secant, I've got my middle term. Sine squared over cosine squared is tan squared. Hot dog. Now I'll finish the proof. So I'm going to come over here. I know what I want. So secant squared is 1 over cosine squared theta. I'm going to repackage this piece as 2 times tangent is sine theta over cosine theta. Secant is 1 over cosine theta. Tan squared is sine squared over cosine squared, you see. And so now, putting these pieces together, 1 over cosine squared theta minus 2 sine theta over cosine squared theta plus sine squared theta over cosine squared theta. And since those denominators are the same, I can put these numerators together as 1 minus 2 sine theta plus sine squared theta over cosine squared theta. I'm almost there now. Now, cosine squared theta, you know, is 1 minus sine squared theta. One minus sine squared theta, you know, is 1 minus sine theta times 1 plus sine theta. And up top, this would factor as sine theta, and a 1 minus sine theta squared. So look what I've got. This 1 minus sine theta would take out one of these, and I'm left with 1 minus sine theta over 1 plus sine theta, which was the object, and my proof is complete. That said, I erase this side of the proof, showing you how I take the right side and transform it into the left. And once again, my challenge for you would be to now take the left side and transform it into the right. So here are 2 examples of proving, or you could say verifying, trig identities. Hope you enjoyed it. Remember, all of this is for your success. Have a great day.